In organic molecules, electrons are not locked in one place. They can be shifted by the influence of nearby atoms or groups. This movement of electrons is called the electronic displacement effect. It governs how reactive, how stable, and how the properties of an organic compound will be. Broadly speaking, electronic displacement effects fall into two categories: permanent effects and temporary effects. Permanent effects include, between each, the inductive effect, the resonance effect, sometimes called the mesomeric effect, hyperconjugation. Temporary effects include the electromeric effect, the inductomeric effect. Today, we will focus on the inductive effect. Whenever a bond forms between two atoms of different electronegativities, the shared electrons in that sigma bond shift slightly toward the more electronegative atom. This creates a permanent partial charge and pulls electron density along the chain of atoms. There are two types of inductive effect. First, the positive inductive effect. That is, when the bonding electrons are drawn toward a carbon atom, we call it the positive inductive effect. Second, the negative inductive effect. When electrons are pulled away from the carbon toward a more electronegative atom or group, that is the negative inductive effect. Understanding these shifts helps us predict how different substituents change a molecule's behavior, and lays the foundation for countless reactions in organic chemistry. Properties of the inductive effect. It is a permanent and partial displacement of seam electrons. It is a permanent effect and a weak effect. Electrons will never change their atomic orbital. It is a distance-dependent effect. As the distance increases, the inductive effect decreases. Only 10% of the original charge transfers in each bond, and by the fourth carbon, the induced charge is nearly zero.